Hey everyone, and welcome. Today we're going to investigate an invisible force that, believe it or not, controls almost every single move you make. To get our heads around it, let's start with a really simple everyday question. You know the feeling, right? One second you're trying not to fall on an icy patch of sidewalk, and the next you're walking up a set of stairs without a second thought. It's a totally different experience. But what's really going on there? What's the invisible thing that makes them so different? I'm sure you've seen these before. Those rough sticker-like strips on the edge of stairs. We all kind of know they're there to stop us from slipping. But how? What is that rough texture actually doing? It seems so simple, but it's the key to this whole thing. So, to figure this out, we're not heading to some high-tech lab. Nope. We're going to do a little thought experiment, one you could easily try at home. Let's dig in and investigate this mysterious force for ourselves. Okay, here's our game plan. It's super simple. We're going to look at two things. First, how the texture of a surface changes the situation, and second, what happens when we change how heavy the object is. Let's do it.
All right, first up, the surface itself.
We want to see if a smooth surface acts differently than a rough one. So picture this. You've got a water bottle and you've put a glove on it. First, you pull it across the table with the smooth fabric side of the glove touching the surface. Then, you flip it over so the rough, grippy rubber side is down and you pull it again. So, which pull do you think is going to be harder? I bet your gut is already telling you the answer. Yep, if you thought the rubber side, you nailed it. It takes way more oomph to pull the bottle when that rougher surface is making contact. So, that's our first big clue. Texture really, really matters. Something about that roughness is creating more pushback. Okay, on to part 2 of our investigation. The weight. This time, we're going to keep the rough rubber side down, but we're changing something else. First, imagine pulling that bottle when it's light, with just a little bit of water in it. Now, picture filling it all the way to the top. It's much heavier, and you pull it again. The surface is exactly the same, right? But adding all that weight completely changes how it feels to pull. It's a huge difference. And yeah, no surprise here, the full, heavy bottle is much tougher to get moving. So now we've got 2 huge clues. This force we're looking at gets stronger when surfaces are rougher and when objects are heavier. We've been playing around with this invisible resistance, this thing that makes objects harder to move. It's about time we gave it a proper name. So, what exactly is this force we've been investigating? Well, it's called friction. It's the force that pops up anytime 2 surfaces try to slide past each other. And you know why? Even a surface that looks perfectly smooth, like a polished table, is actually covered in these tiny microscopic bumps and grooves. Friction is basically all those little bumps catching and snagging on each other. And here's the really crucial part about friction. It's direction. Friction is, well, it's kind of stubborn. Whichever way you try to push or pull something, friction always pushes back in the exact opposite direction. It's a force of pure resistance. You know that little experiment we did with the bottle and the glove? It wasn't just for kicks. It actually showed us the 2 fundamental rules that explain how friction works everywhere in the universe. So let's put it all together. Our experiment taught us 2 huge things. Rule number 1, the surface matters. The rougher it is, the more friction you get. And rule number 2, the weight matters. The heavier an object is, the more friction it creates. That's it. Those 2 simple ideas are behind everything. So now that we know the rules of the game, we can start to see how we humans use them to our advantage all the time. We are constantly and very cleverly either cranking friction up when we need it or dialing it way down when it's in our way. And this shows the 2 sides of the coin perfectly. On one side, we're trying to increase friction to get more grip, like tire chains digging into snow. On the other side, we're trying to decrease it to move faster and smoother, like putting oil on a bike chain. So when a gymnast puts chalk on their hands, they're using rule number 1. They're literally making the surface, their hands, rougher. That increases the friction and gives them that solid, secure grip they need to not go flying off the bars. But on the flip side, when a skier waxes their skis, they're doing the exact opposite. They're making that contact surface as smooth as possible. The wax fills in all those little microscopic imperfections, which cuts down on friction and lets them glide like they're flying. I love this quote because it just sums up the whole idea perfectly. We spend so much time fighting against friction to be faster, but at the very same time, we completely depend on it for the most basic things. It's this amazing paradox. And that's the final thought I want to leave you with. We've been talking about skis and stairs, but just think about walking for a second. The only reason your foot doesn't just slip out from under you when you push off the ground is because of friction. So the next time you take a walk, just take a moment to appreciate the unseen force that makes every single one of your steps possible.